Okay, so I told my 7th period to take the calculators from under the desk and bring them to the top, but some of them didn't, so check under your desk because there might be calculators under there if you don't see one. So, okay, let's do that. So we're going to take 4 and then substitute in a 10 minus 3. 4 times 10 is 40. And what is 40 minus 3? 37. So what answer would you pick? B. All right, so now let's go to our notes. Yesterday we graphed a square root. Today we're going to graph cube root. So in your notes, go to page 7. Now all of these are the same as a square root function. If a is negative, a is still in front, we're going to flip it or reflect it. That's what happens when a is negative. Okay, and this is a. If it's greater than 1, it's going to stretch. And if it's between 0 and 1, it's going to compress. Now remember, a is always going to be in front. So a is in front. Okay, and then we have our h. H is under, and it's also opposite. So whatever you see is the opposite. So if you get something positive, it's going to move to the right. But if it's negative, it moves to the left. And lastly, you have K. K is in the backyard. If it's positive, it moves up. If it's negative, it moves down. So a cube root is the opposite of a cube. All right, so let's go ahead and graph y equals x to the power of 3. All right, so we're going to just do -2 to +2. If you take -2 times -2 times -2, go ahead, type it in your calculator. Type -2 times -2 times -2. What you get? -8. -1 times -1 times -1, -1. 0 times 0 times 0, 0. 1 times 1 times 1, +1. 2 times 2 times 2, +8. Let's go ahead and graph that. This is y equals x to the power of 3. And I'm going to actually change the notes just a little bit. I'm going to put the domain and range for both of these. Now, if you look at your table, notice that you have positive and negatives on both sides. So the domain for this function is negative infinity to infinity. That would be your domain. The opposite of taking something to the power of 3 is the cube root. So let's go ahead and find the inverse. So I want you to take your table and flip it. So we're going to take all of these numbers, put it under the y. And then you're going to take all of these numbers and put them under x and graph it again. So let's flip our table. So now we have negative 8, negative 1, 0, 1, 8. And over here we have negative 2, negative 1, 0, 1, 2. Go ahead and graph that. So 3 of the points are the same. And that is your inverse. And the inverse also has the same domain and range. So remember, for a square root, we had these rules that we had to look at, which I don't think I wrote on the board first period. But for a square root, the domain is h to infinity, the range is k to infinity or negative infinity to k. But for a cube root, it's always going to be negative infinity to infinity. Okay, so that makes it easier. So these are a little bit easier to graph. So we're only going to do a few together, and then we will finish the homework, and that'll be it for today. So let's go ahead and practice graphing some cube roots. So let's go to page 8. We're going to skip example 9. So you can cross that one out. We're going to go to example 10. All right, so let's start off by graphing our parent. So this is our parent. So go ahead and graph this. Let's graph it. So we're going to put a point at, I'm going to graph the parent in black. Negative 8, and then we got 3 dots going up like this, and then 8 up 2. This is the parent. My iPad is kind of greasy because it does not want to write. All right, that's the parent. The good news is that we can automatically answer this right now. Because if we're talking about a cube root, that's what it's going to be. So now let's look at our new function, which is right here. And what's my A, H, and K? So what's the number you see in front? What's the number in front of 3? What is that going to make our graph do? Stretch. What's H? 0. So it doesn't go left or right. Demarion, what's K? Negative 4. What's that going to make the graph do? Down 4. Good. All right, so let's do it. So nothing, we're adding 0 to x, so that doesn't change. So these numbers are going to stay the same. But we're going to take our y value and multiply them by 3 and then add negative 4. All right, so go ahead and do that. Take a minute to get your new y values. So you're going to take -2 times +3 plus -4. Then -1 times +3 plus -4. So take a minute and get all of your new y values. All right, compare your answers with what I got. Did you get -10, -7, -4, -1, and +2? All right, let's graph it. So I'm going to put a point at -8, -10. So that's going to be way down here. Then -1 is stretched all the way down to -7. And then 0, -4, 1, -1, 8, +2. So you look at that red graph, you can see that it is stretched and it moved down 4. And that is a cube root. Can I see the other side? The back page. Or no, this one. Okay. All right, yep, we just got 2 more. So let's go to page 9. Graph the parent again. So let's graph our parent. And we can fill in the domain and range. Oops, I put that point in the wrong place. So now what's the number in front? 0.5. So this time it's going to get flatter, which is the same as compress. Under the roof. Libby, what do you think H is? +1. Good. And what's that going to make it do? Anybody remember? Go to the right one, yep. You said rest.
I said compress.
Oh, compress. Oh, no, that makes it go right. All right, what about K? Oh, okay. K is 0. So now we're just adding 1. So we're going to take our H values, add 1. And to our Y values, we're multiplying them by 0.5. And then we're adding the 0, which of course you don't have to add 0. You just really need to multiply by 0.5. So take a moment using your calculator, get your new 5 points. Go ahead, apply those transformations. Uh-oh, my iPad wasn't charging. It's gonna die. I'm gonna have to put this on the charge. And we're gonna have some decimals. So we just do the best we can. They don't have to be perfect. Oh my goodness. All right, so these are the points I got. So let's go ahead and plot it. So -7, down 1. At the 0, it's like halfway down. It's a little bitty point in the middle. Let me go ahead and zoom in. Then at 1, 0. Then at 2, we go up just halfway. And at 9, we go up 1. So compress, can you see how this blue graph looks flatter? That's what it means when we say compress. It's flatter than the parent, which is black. So the blue is my cube root, and the black, well, that's my transformations, I meant to say. So blue is my transformation and black is the parent. All right, we just got one more. Let's do it. Graph the parent, for example, 12. Let's go ahead and graph our parent. So this is going to have 4 changes. This has 4 transformations. So first of all, because A is -2, this one is going to reflect because of the negative, and because of the 2 is also going to stretch. So I have to multiply all these numbers by -2. And then what is H? Is H +2 or -2? -2. So what's that going to make our graph do? Left 2. So I'm adding that H to all of my X's. Lastly, what's K? And what's that going to make our graph do? Go down 3. Good job. All right, so go ahead, pick up your calculators. Oh, we can fill in the domain and range. because that never changes no matter what. All right, pick up your calculators and apply your transformations to the parent. Get your new 5 order pairs. Okay, this is what my graph looked like. And if you compare it, you can see that it did flip. It does stretch. It moved left and it moved down. So after you finish out that note, take out your homework and we're going to finish it out. So let's finish matching our graphs on our homework. We already matched 3 and we left 3 blank. So we have 3 left to match. So this is what the parent of y equals x cubed is. So letter E, that's this graph. This is letter E. So now we have to figure out which one of these graphs looks like the parent. This is the parent. So would you pick B or C? Which one looks like the parent when you graph it without doing any transformations? Which one looks like the regular parent? C, good job. Which means that B is what it looks like when it reflects. All right, flip it over to the back. There should only be one question left if you did 5 and 6, and that's this one here. So let's go ahead, graph our parent, and we can easily fill in our domain and range for both of them. We already know what these are. So we can answer letter B and letter E. And when you graph it, let's see, this here, -1 down 1, 0, 0, 1, 1, 8, 2. We go ahead and connect that. That's your parent. All right, so looking at this graph or this equation right here, what do you think for this equation? Let me zoom in. What is my A, H, and K? So what's the number in front? 1. What about the number under? -1. And the number in the backyard? -2. So we have a 1, a -1, and a -2. So because of that -1, what is that going to make our graph do, that -1? What am I going to write in this box? Left 1. And what about the -2? Down 2, good. All right, so all you have to do is apply your transformations. Add the -1 to all of these. We don't have to worry about multiplying by 1 because that doesn't do anything. And then when you're done, which you should be able to finish it today, turn it into this blue tray. So use this time to finish out homework 1 and get it turned in.